Hi students. Hi students. Okay, so I'd like to just a brief review what was discovered in the last laboratory work. It was about the stack frame. So once you call a function, you have to set up the stack frame, and the stack frame is pointed by two pointers. One is the base pointer, and the other is stack top stack pointer. But as you know, the stack grows from the high address to the low address. So generally, the base pointer is more higher position, and stack pointer is the more lower position. So anyway, you should remember that you have to remember that there is two pointers. One is the base pointer, and the other is a stack pointer. And in the architecture of x86, so they have another notation for EBP or ESP, which means that it is extended stack pointer, extended base pointer. So actually it is for, it can be used for other registers such as AX and BX. They have another convention for EAX means the extended, and EBX means extended by BX. So that is a 32-bit size register. Okay, so sometimes they call RAX, RBX. That means 64 bits of size of a register. So that is just a convention. So I can make it review in your handout of the last lecture note. So this is the handout of the last lecture note. You know that there is a stack frame, and the important points of the two things is that you are going to have two pointers. One is here, one is a base pointer. So let me just mark this as a base pointer. The other one is a stack pointer. And your stack frame can be depicted like this. So if your stack grows upwards, you have a base point to here, and stack pointer is pointing to here. So if you call another function, and you have the role of changing the base pointer should be saved here, or the base pointer should be saved here, and BP is reset to this point, and stack pointer is reset to this point. Okay, so you have to push the arguments. So the pushing the arguments and setting up the registers is called the calling convention. Okay, so do you have any questions on the material of the last lecture? The question: does the stack pointer points to the full TOS? What is TOS? What do you mean? Top of stack. Top of stack or empty offset. You may think that it is pointing to the top of stack. Okay, but it doesn't matter because the stack pointer may be empty slot or maybe just top of stack. It doesn't have any difference. Okay, because it is just for your subprogram's role. How can I extracting the arguments? It is from the subprogram's role. It depends on the system, but it doesn't matter. It doesn't matter exactly. Okay, it is just off by one. So you may assume that stack pointer is pointing to the top of stack. Okay. Any other questions? No questions? Okay, then let me jump to today's lecture note is not posted yet. Okay, so where should I post it? In your lecture board? So I have to store this, this one. Okay, so I'll take a look of your lecture board. Slide. Okay, so I'll post it. I'll post it now. Lab 3. What was it? System course. Sorry for late posting, dear students. Today's topic is system course, especially for Windows. Thanks. So I'm currently posting it. Slightly. Okay. So you can check it now. So if you don't have any further question on the material of the last lecture, I just switch to the today's topic, today's lecture note here. So you may generate a code for Linux, but sometimes you want to generate a code for Windows. So I'd like to explain the Windows system course in the context of system course of Windows. So this is my first question. Do you know the difference of the open and fopen in Unix? So while you are learning curve of your curriculum in PNU, you are learning Python and C, and in the second grade you are learning Unix and Java and C++. And this may be your third year. So Unix, in the Unix system, you can find there's two similar functions. One is open and the other is fopen. And currently it's answering that fopen is a library function and open is a system call. That's correct. System call can be considered. The latter is, this one is a library, especially standard library. And open is a system call. And the relation of the library and the system call is about like this. If you write a C code, the best thing is that use a standard library here. But sometimes you want directly call the system call, which was provided. So if you are using system call, then your program is dependent for a certain system. So your system call may treat other things. So your standard library will eventually call your system call. Okay. So underlying system is, as you know, is the operating system. So in Unix, open is provided by your operating system. So if we are using fopen, it will eventually call open as a system call to open a file. So the compilers may consume a set of standard library functions, but not always, because you are making a compiler. So in the latter case, you have to use the system calls to provide provided by the operating system at hand. So the structure is much like this. Remember that you are writing this code, okay, but sometimes you have to use standard library. Sometimes you need to call systems, okay? So the only thing to remember, you should follow the calling convention. Anything will do, but just follow the calling convention to use the system call. And the calling convention is very simple, just stacking up the arguments and just call it. And from the returning it, you may assume that the returned value is located on the stack top or a certain register. And for Windows system, the certain register is usually A register or D registers. So let's take a look with Go tools. So in order to practicing system call, you have learned the Unix system. So I'm focusing here for Windows system. So Windows systems, you need to other tools, additional tools for analyzing the Windows assembly. So Go tools is free. You know that Go tools are free. For Microsoft toolchain, there's Microsoft MASM, MASM, but this is not free. But Go tools is free. It is written by Jeremy Gordon, and it can be useful. So just visit gotools.com. So let me just visit here. And then you can find it. So I reshare this screen. You can find it, this kind of tools, and you need this one, GoAsm. So download GoAsm, and you need this one, linker. So there's two other tools, which is resource compiler and debugger, and it is not so needed because you're not going to handle Windows programming using assembler. So just click this GoAsm and linker. So let me click this. I already clicked that. So let me show this in your assembly. In your download page. So go tools. So in your download page. So I can reshare this. Reshare what? This one. Okay. So once you download the Go tools, you may extract the GoAsm and GoLink. Okay. And then just copy. So let's show this in. So just copy GoLink. So just copy it to, in my case, it is D drive. So let's jump to WinGW home. So in WinGW home, you can take a look bin. So just paste it. So in my case, GoLink is here. In the same way, you can copy GoAsm here, GoAsm with additional help file, and then go to GW home. Then in the binary folder, this was added in your path. So just paste it. So in my case, GoAsm is pasted here. Okay. So once you have done, you can take a look in your command prompt. So I'd like to reshare my command prompt. So in your command prompt, you can say that where GoAsm. where GoLink. Okay, so if it is done, so you are all set. So once you are setting the Go tools, then I'd like to reshare the handout. So this is just a description. Just download GoAsm and GoLink and copy them to this folder, WinGWBin. Copy them to this folder. And to test Go tools, enter the following assembly code. So I'd like to just show this assembly code from your command prompt. So in the command prompt, you can check that VIM, what was that? Hello ASM, hello.asm. So this is your assembly code. So beware that you have to save this as those format. So if you are not setting it those format, so let me just show you that if it is not, what is the problem? Okay, just copy this section. And if you'd like to VI for new, hello, hello Unix.asm, and you'd like to paste it from the buffer, so you may think that this is good since it has the same contents with the handout. So once you save this, and you can check it, dir hello unix.asm. It seems correct, but if you'd like to go ASM with output, file output is hello unix.obj from hello unix.asm, it reports an error. So that means your current version is somewhat not readable by GoAsm, because your GoAsm is assuming that your file format in those format. So you can check it by using general notepad, or just type hello unix.asm. So it seems correct, but it is not. Notepad hello unix.asm. It seems correct. Okay. So okay. So you can check it. You can check it from the notepad. I'd reshare this. Reshare the notepad. You may think that this is fine, but it is not good, because it is currently in Unix format. That means the line ending is used just with a single character. Where can I get the difference? Okay, so let me just reshare this from. So in that case, you have to save this. You have to save this. Save as. So save as text, or ANSI, and this is not a good location where it is. Compiler code, compiler system call, or here hello those system calls, hello those asm, okay, with all files. Okay, save this, and you can reopen. It is still Unix. Okay, so let me reopen. in your here. So you can take a look. Hello DOS.asm. It is still in Unix mode. So in VIM, you can change it very simply. Set file format as DOS. This is very simple. Just save this. So you can check it. It is currently in DOS format. Okay? Can you find this? DOS format. Okay? So set ff. I type it here. In VIM, set ff DOS is enough. Okay? So once it is saved as DOS, so you can save it WQ or Shift to ZZ is okay. Then you can do the same thing. GoAsm file output hello.obj and hello DOS.obj and hello DOS.asm. Okay, so it is correctly created, and then you can create. So you can create that GoLink console hello DOS.obj and corner 32.dln. So it will link with the DLL files, which is containing the Windows API functions. So hello DOS.exe is created. So you can just make it sure dir hello DOS. So the executable is just created. So you can execute it hello DOS.exe. Hello GoAsm. Okay. So let me decipher the hello DOS.asm. Okay, in your VI. Hello DOS.asm here. So it has two sections. The first section is data section. So you can declare. So you may think of that. This is a variable declaration. Since it is for declaring the datas. So this is double data. So double data. Double means it is a word. So this is another section, and you may think about this as a code section. So you may think about this as a function declaration. Function definition. And the function starts here. So you may think this is a main function, and it starts here. So this is a function call. This is a function call. It is calling get standard handle. So it is calling that this is some other code. Get std handle with -11 is the argument. So argument is pushed here. So this is another function call. This is another function call. And you may think that it has push. So you may think the argument is just 3, but it is not true. So it is a function call for write file. But the argument, so you know that the push is twice. Push is twice. The push is twice. So this is just a push once. So the argument is 5. The first argument is the contents of EAX. The contents of the register. And second argument is hello GoAsm. Hello GoAsm. Actually, the address of it. And third argument is 12, which is the length of this string. And fourth argument is address of. So let me just use the C notation, address of keep. So keep is declared here. And the last argument is 0. This means that you are not, you are just using default behavior. So this is a write file. So you are calling write file, but before that, you should push all the arguments to the stack. Okay, so what is the result of that call? It is returned to EAX. So EAX will contain the number of characters printed. So in this case, 12 will be stored in EAX, and so you are applying XOR to EAX. That means the EAX becoming 0. Okay, so it is returned from here, returned from the start. So that means your main function is returning 0. So this is not mandatory, but you are following the convention. So it is like that, return 0. These two code is like return 0. Okay? Any questions up to here? No questions. So you may wonder that if this is true or not. So I can show you. I can show you that the same is true for if you are pushing 0 for first one and push address keep for the second one, push 12 and push hello GoAsm. So you are pushing 5 arguments in reverse order and calling write file. You just modified it. And I'd like to try GoAsm file output hello.obj. So using hello.asm. Okay, and GoLink console hello obj and corner 32.dll will generate hello.exe, and you know that hello GoAsm, and it is that the result is same hello DOS, which is previous result. Okay. So I'd like to switch it to your previous handout. So remember, you can build this code with these 2 commands. First command is GoAsm, and second command is GoLink. Okay, so this has the system libraries, system calls. Beware that above code should be entered in DOS mode, implying that every line should end carriage return and line feed. So it is somewhat tricky in DOS mode. The line end is a carriage return and line feed pair. In Unix mode, only line feed is used at the end. So you can check the size of it. So you can just check the size of them after changing the file format. Any questions up to here? No questions? Okay. So beware that above code should be entered in those. This was explained. The system calls on Windows can be referenced using docs.microsoft.com. For example, the API of getSTD handle, which was the first system call, can be found here. Microsoft.com Windows console getSTD handle. Can you show how to change DOS mode? I said ff.dos. You can check it here. So what is your name? Hey, what is your name? I cannot find you. maybe in Korean, arogyo. Okay, arogyo. And so you can just click this get STD handle to open it. So let me share this. So can you see the syntax of get STD handle? So it is just accepting handle ID. So the STD out is just -11, STD in is -10, STD error -12, and then you just call it. So that's why I just entered -11 here. So -11 is for standard out handle, and you are calling STD handle. So you are calling the system call here. For another argument, you are pushing 0, address keep 12, hello GoAsm and EAX, which is the result of the handle. Then you are calling write file. Okay. So the other things you can take a look of write file from the second link. Okay. So that's it. Do you have any questions up here? So if you don't have any further questions, so let me just switch it to the laboratory handout. And today's problem is just exercising how to hacking the system course. As a warming up exercise, modify the above code to write to the standard error stream rather than the standard output. So once it is successful, you can check it using the redirection. So let me just check which one that same. So I have two versions, which was okay. Just let me reshare this command prompt. As you know, the hello output is for the standard out. You can store it hello to hello.txt, hello.out. Okay, so nothing is shown in your standard output, so you can type hello.out, and the contents of it is like this. Okay, but I just made the second one. So once you redirect it to the standard error, in my case H2, it seems similar to the hello, but H2.out, it still goes to the standard out. So that means it is not standard out, it is a standard error. So when you type H2.out, it is nothing, it contains nothing. So in order to store the standard error, it is number 2, not number 1. So number 2, so you can just save the hello standard out can be stored hello.out. Okay, so the contents of hello.out is like this. So for H2, it is redirecting to standard error, whose number is 2. So 2 is redirected to H2.out. Then nothing is here. And you can type that H2.out is the contents of a standard error. So you have two streams intermixed in the standard screen. Okay, so the first warming up exercise is just switching the handle number to the standard error. So once it is successful, you can check it using the redirection and refer the Windows system call page to find the specification. This is the warming up exercise. And as a second exercise, to the Windows system call page to find the specification will read the file. And then write a code to read 5 bytes from the standard input and print it to the standard output. And also, your program should print the suffix except the first character to the standard error. So to declare buffer to save the user input, you have to reserve 5 bytes. You may refer the GoAsm manual page. So you can click the manual page here. And you can find various items here. So this is just an exercise. So you have several other options. First one is to produce gas code, and second gas code for Unix, and second one is for produce Windows code, and then link your friends, the compiler friends will do that. And I will show you the third option that will be explained after the code generation. So this is maybe the last laboratory work for exercising runtime system. Okay, so if you have encountered any further questions while you're doing your laboratory work, please use your Q&A board. Okay, so if you don't have any further question, let's call it a day. And thank you for all for joining this lecture. Bye-bye. See you next time.